Multiplying and dividing algebraic expressions is pretty straightforward for the most part, but it gets a little trickier once we get into longer expressions. So let's start with some simple expressions. Let's say 3 times 2x. Now, what does 2x really mean? It really just means 2 times x. So really we just have three different things here that we're multiplying. 3, 2, and x. And it doesn't matter the order in which you multiply things. So if you want, you can actually just rearrange these and write this as 3 times 2 times x. And the only thing that can be simplified here, or regrouped if you like, is the two numbers, the coefficients. So these two numbers here, the 3 and the 2, you can multiply those to get 6. And we end up with 6x. And once again, if you're unsure about this, feel free to substitute some value for x. So for instance, if I replace x with 5, I have 3 times 2 times 5. Well, that's just 3 times 10, which is 30. And sure enough, if I replace the x in the expression above with 5, I also get 30. 6 times 5. So how about 5x times 4x? Again, I've put these things in brackets to think of the two different expressions. 5x is one expression and 4x is another expression. But when you're multiplying monomials, which are polynomial terms, algebraic terms that don't have a plus or minus in them, it's really just a string of things that you're multiplying. So really what we have here is we have a 5, we have an x, we have a 4, and we have an x. And we can multiply those in any order we like. 3 times 2 times 5 is the same as 5 times 3 times 2. It doesn't really matter the order in which you multiply them. So if you think about rearranging these and put the 5 and the 4 first, and then multiply the x and the x, now we have a couple of different groupings. The 5 and the 4 multiply to give you 20. The x times x multiplies to give you x squared. Right? When you multiply something by itself, you have x squared. Or you can think back to the laws of exponents. If there's no exponent written, there's really a 1 there. So same base, add the exponents. 1 plus 1 gives you 2. So this is 20x squared. And again, feel free to substitute some value of x to see if this holds true. How about 7x times 2y? Again, just rearrange the terms. The 7 and the 2, the two coefficients, you can multiply to give you 14. There's nothing you can do to group or simplify the x times the y. It just stays as x times y. And so you end up here with 14xy. And if you want to test this, you've got to pick a value both for x and for y. They can be different or the same. Should work out fine. If you're testing it, probably not a bad idea to pick different values for x and y. And you should find out that it works out fine. So let's take a look at a couple of more complicated monomials. 2x squared times 3xy. Alright, so we have a 2, we have an x squared, we have a 3, we have an x, and we have a y. We can group the two coefficients together, 2 times 3. We can group the two expressions which have the variable x together, x squared times x, and then we have the y. So again, what simplifications can we make? The 2 times 3 gives us 6. Using the laws of exponents, the x squared times x gives us x cubed. And then we just simply have the y. So all we're really doing here is just regrouping. All right, we're replacing 2 or perhaps 3 things with 1 just by multiplying them. And again, you can substitute a value for x and a value for y, and this should work. Now here's where it starts to get just a little bit trickier. When you have polynomial expressions that have more than one term, and you can tell they have more than one term because there's a plus or a minus in there. So the x plus y in brackets is something called a binomial. There are two terms, bi, whereas the 5 or the 2x or even above the 3xy, these are called monomials, just one term. You're just multiplying a bunch of things together, but there's no addition or subtraction. So if we're multiplying something involving a binomial or something with even more terms, we have to take advantage of something called the distributive property. Now, one way to think about the distributive property is that everything has to get multiplied by everything else. So the 5 has to get multiplied by the x, and the 5 also has to get multiplied by the y. A nice visual way of looking at this is to think of an area model of multiplication. So think of a rectangle with a height of 5 and a width of x plus y. And we can sort of partition that rectangle into two parts, one part having a width of x, one part having a width of y, and then we can just find those two little areas. And when we do that, the multiplication is just like above. It's a monomial times a monomial. This part on the left is just 5x, and this part on the y is just 5y. And so together, we end up with a total area of 5x plus 5y. And let's try it again for a slightly different expression. Again, the 2x has to be multiplied by the 5x and by the negative 3. So if we look at these two little regions over here on the right with this area model, the 2x times the 5x, 2 times 5 is 10, x times x is x squared. That's the area of that little region on the left. The region on the right is 2x times negative 3. So it's a positive times a negative, which means it's a negative. And the 2 times 3 is 6, and we have an x. So the full product here is just simply 10x squared minus 6x. Let's take a look at one further example. This time we have a binomial times a binomial. Alright, so if you have a polynomial with two terms multiplied by a polynomial with two terms, there's actually going to be 4 intermediate products. So we have an area model on the right with 4 different regions. The height is sort of subdivided into x and 2. The width is subdivided into x and 3. So in this way we can think of just 4 separate products. The x times x, this region on the top left, is x squared. The x times 3 is simply 3x. The 2 times x on the bottom left is 2x, and the 2 times 3 is 6. So this works out to the 4 intermediate products are x squared plus 3x plus 2x plus 6. And now we have to use a skill we learned in the last lesson, which is simplifying these expressions. There are two terms here that are like terms, the 3x and the 2x. They both have the same variable with the same exponent, and so we have to combine these if we want to write this in simplified form. The x squared doesn't have any like terms that we can combine it with, but the 3x and the 2x become 5x. And so we have x squared plus 5x plus 6. And again, if you want to test this, pick a value for x and substitute it in, multiply it, see if you get the same value as when you substitute x or whatever value you chose for x in the final expression. It should work out fine. We're going to get a lot more practice with this in subsequent lessons.